All right, this next video here we are going to talk about piecewise functions. So a piecewise function is another way of saying that you're making one whole function that is made up of pieces of separate functions. And the important thing with these is just to be able to kind of recognize how to graph them, and then also be able to locate what the domain and the range are from them. And there are some cases in statistical modeling where this is actually a thing, so it's not completely irrelevant and weird like some of the other algebra topics they try to get us involved in. This is a real thing. So let's dive in and take a look. We got three problems we're going to look at. So this first one, they're saying that f of x is comprised of both of these functions. So the way we read this is it's saying, well, the first part of this function, or one part of the function, is this line right here, is x minus 3. So right now, let's completely ignore the rest of this, and let's just plot the line x minus 3. So if I plotted the line x minus 3, I'm going to use slope-intercept form. It has a slope of 1 and a y-intercept of negative 3. So I'm going to go down to negative 3, right? I'm going to put a point, and then I'm going to plot a slope of 1, so I'm going to go up 1, I'm going to put another point, another one, up another point, and so you get this line that kind of goes up like that, right? But this is where we have to take into account the other part of this, and we have to take in, it says, but only if x is greater than 1, all right? So a couple changes I got to make here. First of all, I'm not going to include this point because it's 0. It's less than 1. And then the actual point itself of 1, we have to change to an open dot to show that it's all the points that lead up to that but does not include 1. And then anything else that x is greater than 1 is included in this. So you have a line that's going to have the same shape and the same slope as the other one we were drawing, but it doesn't go past negative 1, or 1, I'm sorry. It does not go past 1 for x, all right? So that's good. All right, and then we're going to kind of do the same thing with this one right here. We're gonna look at this and we're going to say, okay, let's do a different color. We got negative x plus 3. So my y-intercept is 3, so it's up here. And negative x means it goes down 1 and over 1 because it's a slope of negative 1. So that would give me another point right here. And then because it's less than or equal to 1, I do include this point here, so that's going to stay, but I don't go past that point. And then anything to the left of that point is going to be included. So your line on this one is going to look something like this. And so you get this kind of funky looking graph. All right, and so now the hardest part, honestly, with these is determining what the domain and the range are. Well, you can see clearly that you can put any value of x in for this, and it will work. So your domain is going to be, and I'm going to show you 3 different ways to write this. So set builder notation, you would say this, and then you could say all real numbers. That's how you write all real numbers in this. Another way you could write is you could say D, and you could just say all real numbers, and then I usually use the pound sign for numbers. Okay? Or you can just, say domain is all real numbers. They're all okay because they're all demonstrating that you understand what the domain is. Now for the range, same deal. You take a look at it, and I can see that it looks like I'm not going to have any values below negative 2. All right, so anything here going down, we just don't have anything happening there. But it looks like all of the values above negative 2 for y are represented, because this one here starts at negative 2. This guy right here starts at negative 2, and it continues to go up towards infinity that way. And this one kind of starts up a little higher, but it does the same thing heading up towards infinity as well. So we are going to say that our range is y, and if I did this in set builder notation, it's basically anything that where y is greater than -2. All right? Or you could say range. You could say all values of y greater than -2. All right, those are both accurate representations. I like the set builder notation because it's quick. But if you're more comfortable just writing it out, then write it out. All right, 2 more examples for you. All right, and they're both on this same page here. So let's raise this up a little bit. Let me write on this so it will let me do this. Okay, bring this down. Okay, so let's start with the top one. So this is for values of x being greater than -1. So let's put -1 in. This is another way we can do this. Let's put -1 in this, see what we get. So if I put -1 in this, I'm going to get a f of x value of -2 because it's -1 minus 1, which is -2. So the point -1, -2 is right here, except that I'm not going to fill that in. I'm going to draw a circle around it, like that. Now if I put 0 in, I get -1. If I put 1 in, I get 0. So I get a line that's going up in this direction. Put your arrow on it. Now, for anything that's less than -1, but again, it doesn't include the point -1, all right? If I put -1 into this, it's going to give me a value of 3 because you have -1 plus 2, right? So I will go up and I will go -1, 3. If I put -4 in, or -2 in, sorry, it's going to do the same thing, give me that double negative and give me 2 plus 2. Sorry, I am actually writing this stuff down. It's just not working right. And so that'll give me a value of 4. And so I got to change this to make it an open point, because I did talk about that. And then you get a line that looks kind of like this, except that I drew that really crooked, like seriously crooked. All right, much better. Okay, and the domain and the range for this one are kind of tricky, all right? So the domain is, it's all real numbers, right? So I would say for x, it's all real numbers, except that it doesn't actually include the value of -1. So you would say x cannot equal -1. So all real numbers, x cannot equal -1. And you could write that out with words if you wanted to. Right? And then your range is going to basically be anything that is above, and this one's kind of like the other one, anything above -2 for y. So y, say y is greater than, but not equal to, -2. Okay, and then 6. If you want to try 6 on your own, pause the video. Go for it. Otherwise, stay tuned here. So we're going to do the same thing with this one, and we're starting at 0, which is nice because we can use slope-intercept form for this one. So if I use slope-intercept form for this first one, and this is for all values greater than 0, my y-intercept is -2. All right? Now notice, because it is at x equaling 0, I don't include the point because 0 is not actually included there. So I'm going to put a circle around -2. And then I'm just going to put like maybe one more point in there. So what happens if I put the point 2 in? Well, if I put 2 in, I get -2 minus 2, and that gives me -4. So that works. And you can see that if you did the slope-intercept way of plotting it, it's the same thing. It's a slope of -1, so it's down 1 over 1, right, like that. So you get a line that looks sort of like this. Put your thing there. And then this one, -x, all right, for x is less than or equal to 0, all right? So it's including 0. Well, if you put 0 in, you just get 0. If you put 1 in, or if you put -1 in for x, it does that double negative thing again, and it gives you positive 1. And so you get this line that goes like this, more or less. All right, it's not perfectly straight, but pretty close. All right, so for this one, your domain, this time it's all real numbers again because we're actually including 0. So for x, and then you just say all real numbers. And then for your range, for y, we're saying it's basically all real numbers, except it doesn't include this area right here. So the way you would write that is, that would be the easiest way to write that. And I'm going to give myself a little more room and write at the bottom here. So we'll segment this so we don't think it's included. Let's say the range, now let's say from my y values is y is either greater than or equal to 0, or y is less than -2. All right? It falls in that range somewhere. All right, well, that's how these work. The hardest part, I think, is interpreting the domain and range, but graphing them, just use what you know about graphing and graph them however you like, whether you want to plot points, use slope intercept. You could even, if you wanted to, find your intercepts and do that, but use whatever works best for you.